Hey guys, this is going to be our first foray into attempting to do the flipped classroom teaching model. So I hope you guys will be patient with me. I don't expect this to take more than 10 minutes, so let's get going. So first off, right now you should have right next to you while you're listening to this, your note packet. So your note packet, if you forget what it looked like, it was a pale yellow color. It said Unit 2, Note Forces in Newton's Second Law. We have already filled out page 1, page 2, and page 3 we filled out. If you can't find this note packet, there is a link to the electronic version of it. You could print that out if you can, or you can just take notes next to you based on what you have at home. So whatever works, you let me know if you have any issues with that. So we're going to start kind of a quick review here with calculating acceleration. You guys did some review things last week, so all of this part should be pretty solid by now. So I'm just going to very quickly go through that. All right, so let's get started with our presentation here. Our main focus today is to talk about the equations. So looking at word problems and using equations to figure out how far something goes and how fast something goes when it's accelerating, when its speed is changing. So that's our focus. So quickly, our acceleration, if you remember from last time, acceleration is going to be the slope of the velocity time graph. So if I look at a graph of velocity versus time and I were to calculate this slope, that's going to tell me what the acceleration is. And in fact, our acceleration equation comes from our slope equation. So I'm hoping that maybe you recognize that if I look at what's going on top here, the F is going to stand for final and I stands for initial. It's just like in a math class where you do y2 minus y1 on the top. In physics, we do final and initial, but it's the same idea. V is our y value, and then time is going to be our x value. So it's y2 minus y1, x2 minus x1. Just like in math, except we just give it physics names. And this triangle right here is just a shorthand way in physics that we do subtraction. So the triangle means change in. How is the velocity changing over how is the time changing? So if I calculate the slope of this graph, let's take a look at what's going on. If we start at time t equals 0, after 1 second, we can see that the speed has changed by 4 meters per second, our units, in 1 second. So my acceleration is 4 meters per second per second. And if I look at this point right here, from 1 second to 2 seconds, my speed again has changed from 4 to 8. So my change in speed has been 4 meters per second, again, in 1 second. Same value of the acceleration. In fact, if I pick any 2 points on this line, I'm still going to get that same value of the slope. The slope is what we call a constant slope. It doesn't change. So if I just pick the first and the last point, just as a review, start at 0 and go all the way up to 20. So my change in velocity is 20, and my change in time is 5. 20 divided by 5, 4 meters per second per second. So our units, again, are going to involve 2 time units. And this idea that I can take any 2 points on the line and still get the same value of slope, this is what we mean by something having a constant acceleration. The velocity is changing. Yeah, it's speeding up. No doubt about it. But the amount that it changes by, the 4 meters per second every second, that's what we mean by constant acceleration. The rate the velocity changes is the same. Okay, the units are going to be important. They're going to give us context clues to be able to solve some problems. So let's kind of move on into doing the problem solving now. So the 2 things that we're going to want to be able to do besides solving for acceleration is to figure out how fast something is going and how far something is going. So the how fast question is asking for a velocity. It's in fact asking for the final velocity. And where this equation comes from is just rewriting the acceleration equation. Instead of as a fraction, I kind of put it all in one level. You never need to memorize the equations. I'm always going to tell you what they are. So again, we have final velocity, we have our starting velocity, and then I add to it the acceleration times the time. So this is shorthand for saying multiplication. And the unit, again, final initial, we know that. And then the units for how fast something is going is meters per second. So remember, acceleration is meters per second per second. They have 2 of those time units. Speed is just 1. So meters per second. So we really need to make sure that we know our units. That's very important in physics. Okay, how far is just the total distance traveled. Now this equation, I know it looks a little crazy, but once you get used to it, you'll be fine with it, and we'll take you through all the steps. So the D stands for distance, and distance is how far something is going. We have a 1/2 fraction in front, and then the tricky part here is, again, you have the acceleration times the time squared, but the big key to remember is you only are going to square the time. So you don't square everything, just the t. And we'll talk about some tricks to figure that out when we start plugging things into the calculator. And the units for distance, any length that we measured, is just meters. So we have meters, meters per second, and meters per second per second. And so it seems like it's a lot of the same kinds of words, but we really need to know what the units are. All right, so we're going to do a practice problem right here. So we have an airplane that accelerates from rest at a rate of 1.5 meters per second for 30 seconds. So we want to identify what is the statement telling us. So the first important information is saying that it accelerates from rest. That's telling us that initially the speed is 0. And then we have this 1.5 meters per second. And this is where students struggle. They're like, is that a speed? Is that acceleration? Is it a distance? There's 2 ways to figure it out. First thing, look at the units. We see this meters per second. This is telling us it's an acceleration unit. We can also look at the words. Accelerates from rest at a rate of. The words are telling us that this is acceleration. And then last part is the time. So the time, 30 seconds, I think that one's pretty straightforward. So in the box, you should write down what are our givens. I'm going to give them the variable, and I'm going to say what it's equal to. And that's going to make it easier when we need to plug things into the equations that I gave you. All right, so let's continue on. We want to figure out how fast is it going at the end of 30 seconds. So I got these 3 equations. You'll never have to memorize them. I'm going to give them to you. Which one is the right one to use? So if it's asking me how fast, what does it want? It wants to know the final velocity. How fast is it at the end? So we pick our equation, we write it down, and then we substitute the numbers. So we have our list of givens. My initial velocity was 0. My acceleration was 1.5. My time was 30. I'm just going to multiply these numbers together and put a unit on it. So calculator, 1 is 45 meters per second. So that's going to tell us this is our how fast equation. All right, same problem. How far is it going to go in that same time? How far? Again, which of these 3 is going to be our how far equation? It's asking how far, so that's my distance equation, so I know which one to pick. I'm going to write that down. I'm going to substitute the numbers, and then I'm going to plug it in. So take a minute to pause the video and try plugging it in on your own with the calculator. Here's a little tip. I usually start here first and square the 30 and then work my way to the left with my multiplications. In that way, sometimes students end up squaring everything and then they get the wrong answer. But if you start at this end and work that way, it's probably a better idea. So plug it in, pause. Did we get 675 meters? So hopefully practice it with your calculator. If you didn't, pause the video and do it one more time. All right, we're just going to let you guys do one real quick. Remember, the step 1 is to identify your givens and then look at what the question is asking and identify the equation. So try this out. A car is waiting at a red light, hits the gas and speeds up with an acceleration of 2.5 meters per second for 4 seconds. The first question is asking how far. Which one is the how far equation? The next one is asking how fast. Which one is the how fast equation? Use your equations in your note packets and take a minute to try to solve these problems. Okay, hit the pause on the video, give it a shot. All right, we're back. So I'm going to put the answers up. Let's see how you did. So how far would be 20 meters and how fast is 10 meters per second. So I hope you guys did all right. I'll take your questions in class if you're struggling with it. Please make sure that you bring your note packet to class on Tuesday because that's where your equations are written right now. I can't write them on the front board. Make sure that you bring a pencil, some scratch paper, and your calculator. I'll see you on Tuesday.